Rocking M Studios and Need Steel Education Productions present from the Second Life University of Patton Bay, Washington. Wild World of Science, Porosity, with Professor Callum Dixon.
Greetings, my fine young scientists. In class, you've begun your study of the hydrosphere by examining the hydrologic cycle, or water cycle. Today, we are going to take a closer look at the way in which water moves through the ground. In short, we will be investigating soil porosity and permeability. To do this, you will be using the Gizmo's virtual lab called Porosity. Please press pause or rewind this video as needed during your learning. To access the Gizmo's lab, you must go through your school Clever portal. Once you click on Gizmos and launch the Porosity lab, use the drop-down menu under Lesson Info and click on Google Doc to make your copy of the lab report worksheet. When you have completed the lab, share your report with your teacher. Directions. Follow the instructions to go through the simulation. Respond to the questions and prompts in the orange boxes. Key unit vocabulary includes aquifer, gravel, permeability, porosity, sand, saturated, sediment, silt, and surface water. Prior knowledge questions. Do these before using the Gizmo. 2 students are given cubic boxes, measuring 10 centimeters on a side. Robert puts a single glass marble with a diameter of 10 centimeters in the box. Susan puts 1,001 centimeter glass marbles in her box. Question 1. Whose box has more empty space? Explain. Robert's box would have more empty space because the large marble would not fill in the corner spaces like Susan's multiple small marbles would. Question 2. Whose box will be heavier? Explain. Susan's box would be heavier because there are less empty spaces filled with air. Gizmo warm-up. Some rocks and sediments have a lot of empty space in them. This allows liquids such as water and oil to pass through and be stored in them. Permeability describes how easily liquid passes through a material, while porosity describes how much liquid can be stored in the material. These properties are explored in the Porosity Gizmo. Turn on the macroscopic view of gravel, sand, and silt. Gravel consists mostly of rock fragments greater than 2.0 millimeters in diameter. Sand consists of grains that are between 0.0625 and 2.0 millimeters in diameter. Silt consists of grains that are between 0.0039 and 0.0625 millimeters in diameter. Question 1. Which sediment do you think will allow water to pass through most easily? Gravel, the largest sediment particle, appears to have the most connected pore spaces, so water would most easily pass through gravel. Question 2. Which sediment do you think could hold the most water? Please answer this question on your own and be sure to explain your reasoning. Question 3. An aquifer is a rock layer that stores and allows the flow of groundwater. Compared to other types of rock layers, how permeable and porous would an aquifer be? In order to store and allow the flow of groundwater, the rock layer must be both porous and permeable. Activity A, Permeability. Get the gizmo ready. If necessary, click Reset below each container of sediment. Question: how does permeability relate to the grain size of sediment? Observe. Above the gravel container, click on. Observe water moving through the gravel. A. Does the water pass easily through the gravel? Yes, the water easily flows through the gravel. B. Repeat the same procedure with the sand and silt. What do you notice? Water moved slowly through the sand, but accumulated on top of the silt before very slowly moving downward. 2. Gather data. Surface water pools on top of the sediments. Surface water can indicate that sediments are saturated, full of water, or that the sediments are not very permeable. Click Reset below each container. Release about 100 milliliters of water into the gravel beaker and press Off. Record the approximate amount of surface water you see just after you press off. Repeat the same procedure for the sand and silt. There were 0.0 milliliters of surface water on the gravel. The sand had about 47.6 milliliters of surface water on it. And the silt had approximately 73.6 milliliters of surface water on it. 3. Analyze based on your data. Which is the most permeable sediment? No surface water accumulated on the gravel, so it is the most permeable. 4. How do you know the surface water is not there because the sediment is saturated? The surface water is there because it was unable to fully pass through the sand and silt due to their lower permeability. 5. How is permeability related to the size of the grains that make up the sediment? Larger grain size in a sediment or soil means it will have a higher permeability, while smaller grain size means it will have a lower permeability. 6. Suppose you were digging a well into saturated sediments. Why is the sediment's permeability an important factor in deciding where to put your well? If a sediment is permeable, water will flow easily through the sediment and thereby produce a very good supply of water for the well. Activity B, Porosity. Get the gizmo ready. Click Reset below each container of sediment. Question: how does porosity relate to the grain size of sediment? Predict: which sediment do you think can store the most water? Answer this question independently and explain your answer below. 2. Gather data. Release 400 milliliters of water into each sediment. Wait until each sediment is fully saturated with water. Record the amount of surface water in the first row of the table below. Gravel had about 285 milliliters of surface water. Sand had about 298 milliliters of surface water. And silt had approximately 311 milliliters of surface water. 3. Find the amount of water that is stored within each sediment by subtracting the surface water volume from the original water volume, 400 milliliters. Add this data to the table. Remember, to find the amount of water that is stored within each sediment, you subtract the surface water volume from the original water volume, 400 milliliters, for each sediment type as shown. Add this data to the table. Gravel had 115 milliliters of water in the sediment. Sand had 102 milliliters of water in the sediment. And silt had 89 milliliters of water in the sediment. Calculate. To calculate the porosity percentage, divide the volume of water in the sediment by the sediment volume, and then multiply by 100. Add this data to the last row of the table. Remember, to calculate the porosity percentage, you must divide the volume of water in the sediment by the sediment volume, 400 milliliters, and then multiply your answer by 100. Add this data to the last row of your data table. Following our formula, you should have determined that the porosity for gravel is 28.8%. The porosity for sand is 25.5%, and the porosity for silt is 22.3%. Analyze which is the most porous sediment and which is the least porous sediment. Gravel is the most porous sediment, and silt is the least porous sediment. 6. Draw conclusions. Compare the porosity number to the grain size of each sediment. A. Does grain size determine the porosity of a sediment type? Explain. And B. Explain what you think controls a material's porosity. A. Yes. Grain size determines the porosity of a sediment. For example, gravel has the largest grain size, and it has the highest porosity. And B. Grain size determines the porosity of a material. This concludes our look into porosity and permeability of sediments and soil. Make sure that you turn in your lab report worksheet for grading when you have finished answering all questions. Until next time, be safe, make good choices, and we'll see you again soon.